All right, last little bit. We're going to be solving problems with trigonometry. So we're asked to use a trig equation to find the value of x. Here's x. Now we know one angle measure, and we know one side, and we're trying to find another side. Thinking about the relationship between that angle and that side does not touch that angle, so we're going to call that the opposite side. Now the 74, that side length that we do know, that's the opposite of the right angle, so we're going to call that the hypotenuse. Thinking about what we know about our trig equations. We got sine, cosine, tangent, cosecant, secant, and cotangent. We can use one that uses opposite and hypotenuse. My gut goes with sine. You can use cosecant if you want. I would probably say sine. So we're going to say the sine of whatever angle we have, well, we happen to know the angle measure, the sine of 30 degrees, equals the opposite side, x, over 74. Now we're trying to solve for x. To solve for x, we got to get rid of what's being done to x. So x is currently being divided by 74. We need to multiply both sides by 74. So multiplying both sides by 74, we end up with, on this side, just x. On this side, sorry, I don't know why I wrote a degree symbol there. I'm actually going to not use the calculator yet, because the sine of 30 degrees, we happen to know a little bit about that. Going back to our table, or one of the tables that we looked at, the sine of 30 degrees is a half. We had that earlier. So we end up with, there we go. So it's 74 times a half. Well, half of 74 is 37. So our side length x is equal to 37. Now, this last one's going to be a little more challenging, and we're going to have to rely on calculators. I'll show you how to use the calculators on that in just a moment. But let's start setting this one up. So the tangent, oh sorry, I'm jumping ahead. We're asked to find the missing side lengths, plural, of the triangle below using trigonometry. We're going to assume this is a right triangle, even though it doesn't show up on there. So assuming that it's a right triangle, we have to figure out the other two side lengths that we don't know, and we have to figure out the other angle that we don't know. Thinking about what you might remember about triangles, the three angles of a triangle must add up to 180. So if we're going to call this, let's call this angle theta. We'll say 60.7 degrees plus our 90 degree angle that we do know, plus angle theta must add up to 180 degrees. To solve for angle theta, I'm going to subtract I'm just going to add these two together and subtract. We're going to subtract 150.7 from both sides. Sorry, my stylus is not writing well. 150.7 degrees to cancel that and to cancel that. And we're going to do that on the other side as well. So I'm going to subtract 150.7 degrees, and we end up with theta equals 29.3 degrees. So angle theta is 29.3 degrees. That's our missing angle. Sorry, I'm just reloading something on my computer a second. Okay, so we need to figure out, well, let's start off with this side length here. Couple options we have. We know all three angles. We're going to use one of those two angles. I'm going to pick the one that we were given, 60.7. So in the relation to 60.7, this is the opposite side, this is the hypotenuse, and this is the adjacent side. So since we know an adjacent side to that angle, let's use tangent. The tangent of 60.7 degrees is equal to the opposite side. Well, we don't know that. Let's call that x. X over the adjacent side, 120. Now, to solve for x, we got to multiply both sides by that 120, just like we did in the previous example. Now, in the previous example, we had the tangent of an angle that was on our special table. 60.7 is not. 60.7 is close, but it's not quite there. So let me minimize this, and I'm going to show you how to use this on a calculator. 7. I'm going to close that parenthesis. Now, if we do this, we're going to get a number here, and that seems fairly large. We want to make sure that in the third row here, right now you see it says radian with a dark background. We want to make sure degree has a dark background. So I'm going to go down to that. There we go. Go over to the right, hit enter, and now degree should have a dark background. So if we go second mode, get back to the original, I'm going to retype that same equation, 120 times the tangent of 60.7, and we end up with a fairly different number, 213.83. So again, since we're using degrees in our calculator, we got to make sure our mode is in degree mode. I know some of you use different calculators like the TI-31s or whatever. Make sure those are in degree mode as well for these. So the value that we're going to go with is that 213 let's do 2 decimal places, 0.84. So jumping back to this, we're going to end up with just x on this side, and we end up with 213.84, and the units we're using here are feet. So that's, I'm just going to put that on here, 213.84 feet. Now, the last thing we're going to do is we got to figure out that third side. It does not make a difference which way you do it. You can use the Pythagorean theorem, where we know the two legs. We have a squared plus b squared equals c squared. What I'm going to encourage us to use, especially considering that this number is a rounded number, let's use the exact values that we do know. The exact values that we were given were the 60.7 and the 120. So if we're trying to figure out the hypotenuse, we have the angle measure and we have an adjacent side. So adjacent hypotenuse, let's use cosine. So let's say the cosine of 60.7 equals the adjacent side, 120, over the, I didn't give that a letter. Let's call the hypotenuse y. So 120 over y. Now, to solve for y, we got to get rid of that 120. Right now, it's 120 divided by y. Well, the easiest way to get y out of that denominator, let's multiply both sides by y. So on this side, we have y times the cosine of 60.7. I'm going to put that in parentheses because we're going to need that when we type it, equals 120. Now we got to get y all by itself, so we're going to divide both sides by the cosine of 60.7. Again, let me jump back to the calculator, minimize this, calculator time. So now we end up with 120. Let's see if it'll let me type that. 120, there we go, divided by the cosine of 60.7. Again, just double checking, making sure that we are still in degree mode. Don't worry about the other settings. I changed it from my other class for trig pre-calc. You don't need to worry about the other ones. Just make sure this third one's in degree. So then we have 120 divided by 60.7, and we end up with y equals, we're going to say, let's go 2 decimal places, 245.21 feet. So rounding that to 2 decimal places on our triangle, we end up with 245.21 feet. So our new measures that we did not have before were that hypotenuse, the leg off to the left there, and this angle measure. We solved with the triangle by finding all the measures.